Hi students, today we'll discuss about oxidation number or oxidation state of elements in a particular compound. For example, now I will discuss about, for example, HCl is there. In this HCl, what is the oxidation state of chlorine or oxidation state of hydrogen we want means generally hydrogen have only one electron having. Same chlorine also one electron is there in valence shell, 7 electrons is there but bond forming only with one electron. So in these two between bond will be formed, but these two elements have which is highest electronegative element, that one is pair of electrons shifted from which is highest electronegativity element, that side from hydrogen to chlorine pair of electrons will be moving, like we will imagine means, so nearly closing chlorine side only electrons will be moving. So when this is a distance half means completely the two electrons chlorine atom attract towards itself. So attract towards this side means here one charge is developed, that is a negative charge. Now hydrogen have positive charge. Chlorine have now negative charge. So oxidation state of chlorine is now -1. Oxidation state of hydrogen is +1 in HCl molecule. How can you say that? So valency means combining capacity, but without sign we should say about what is the oxidation state, what is the what is that valence of chlorine means, we will say only valence of chlorine is 1. If oxidation state of chlorine is +1, so we should mention positive or negative sign means this is -1. Positive or negative means that is oxidation state or oxidation number. We will mention with the sign means. So that is oxidation state. Okay. Now example H2SO4 is there. H2SO4. Oxidation state of all elements, how we know? If structure we know means, for example, S double bond O, OH. This is the structure of H2SO4. Now oxidation state of sulfur, how much? So generally we don't know. So how to find? In these two atoms you can take hydrogen and oxygen. Which is most electronegative element? Oxygen is most electronegative element. So this one have -1. So pair of electrons attracted this side, oxygen side only, so that only -1. Now this one what? +1. Oxidation state of hydrogen is +1. Again sulfur and oxygen, which is highest oxidation state, highest electronegative element in these two? This one, oxygen is highest electronegative element, so -1 for this one. This one +1. Sulfur is +1 in this position. Next, in these two atoms, this is most electronegative element compared to sulfur. This one, how many electrons, how many bonds is there? 2 bonds. So from sulfur, oxygen attract or pull 2 electrons towards the oxygen side. So then total 2 electrons, no, -2 for this oxygen. This oxygen also -2. Why? This is -1, this is -1. Totally -2. From this oxygen, this sulfur also. Here to here, 2. From sulfur to oxygen, 2 electrons moving that side. So this is also -2 because compared to sulfur, oxygen is most electronegative element. -2. Next, in this two, this is most electronegative than this one. This is -1. Now this is +1. So these 2 electrons we will see means here -2 means here +2 will come. Here -2 means here +2 will come. Here +2, here +2. For this side +1, for this side +1. Total +1, +2, +2. 4, 5, 6. So sulfur oxidation state is now +6 in H2SO4. Now what about these two atoms? This is most electropositive than this one. For this one also -1, this one +1 will come like this. Next, one more example we will take. Let's see one more example. H3PO4. H3PO4 is there. So here H3PO4, what is the oxidation state of phosphorus means? Phosphorus we will take double bond O, oxygen, hydrogen, oxygen, hydrogen, oxygen, hydrogen. So this is the structural formula, structural arrangement of H3PO4. Sorry, here hydrogen and oxygen, which is highest electronegative? This one. So minus 1. This one is plus 1. In this two also, this is plus 1. This is minus 1. This is plus 1. This is minus 1. So oxidation state plus 1 for every hydrogen, because electropositive element is hydrogen, electronegative elements oxygens. So here also phosphorus is most electropositive than oxygen. Oxygen only electronegative. Here how many electrons pull towards the oxygen side? 2 electrons. So minus 2. For this one plus 2. Next, this oxygen and phosphorus, this is minus 1, this is plus 1. This is minus 1, this is plus 1. This is minus 1, this is plus 1. Plus 1, plus 1, plus 1. 3 plus 1, so plus 2. Total how much? 5. So phosphorus oxidation state is plus 5 in H3PO4. Like we will write. So this is the one more example for finding oxidation state of phosphorus in a H3PO4. So every compound we should write like this. For students it is very difficult. Very difficult. So that only we have one process. That is what? First one, oxidation state we have to find means we want to think about electronegativity of some elements. For example, first A group elements is there. First A group elements in periodic table elements. First A group elements all having maximum plus 1 oxidation state. So second A group elements, oxidation state is plus 2. What is first year group elements? Generally first year group elements means what? We will lithium, sodium, potassium, rubidium, francium, cesium, like first year group elements. Second year group elements what? Calcium, magnesium also is there. So first beryllium, magnesium, calcium, barium, like these elements are second year group elements. This oxidation state is plus 2, maximum oxidation state plus 2 only is there. Now oxygen oxidation state. Oxygen oxidation state. What is oxygen oxidation state? Oxygen oxidation state is maximum minus 2 only is there. 99% minus 2 only in every compound, but sometimes it is minus 1 also is there. Sometimes minus half also is there, oxidation state of oxygen. So where it is, example for that one is in H2O, we will see oxygen oxidation state structural formula like this is there. This is a plus 1, this is minus 1, this is plus 1, this is minus 1. Total minus 2 oxidation state for oxygen in H2O. Next, minus 1 where example F2O is there. F2O and F2O, FO2. F2O2, F O2 like this. F2O2, fluorine, oxygen, oxygen, fluorine. So this is a peroxide. So like this peroxide, it will come positive charge also will come. Highest electronegative element is this one, minus 1. So one bond only is there. This is plus 1. Here this is minus 1, this is plus 1. For these two oxygen peroxide bond, there is no charge. This electronegativity, These electronegativity are equal electronegativity between them. There is no charge separation, so same charge. Now oxygen have, when it is mixed with fluorine, otherwise when it is contact with fluorine, oxygen is +1 oxidation state, also it will exhibit. Now where is -1? This one won't see. We will see this one how much will come. For example, H2O2 example. On this one also we will discuss. FO F2O2 F2O F2O, here F, here F will come. So this one have -1, this one have +1, this one have -1, this one have +1. Total +2 also is there. +1 oxidation state, +2 oxidation state also is there for oxygen. Next, -1, when it will come? -1, for example, oxygen oxidation state, -2 is there, +1 is there, and +2 also is there when it contact with that atoms. Hydrogen peroxide, H2O2 example you can take. Here hydrogen, oxygen, oxygen, hydrogen, this is peroxy bond. So hydrogen is electropositive and this one is electronegative. This one is electronegative, this is electropositive. Now -1 charge is there, -1 also it will exhibit. Both between there is no charge separation because of both are same electronegativities. Both are same electronegativity means there is no charge for these two atoms. For hydrogen this one got -1, for hydrogen this one got -1. So -1 also it will exhibit. It will exhibit. Okay, next. Half when it will exhibit, next video we will discuss. So this is about first year, second year, and oxygen and fluorine. Fluorine always F equal to -1 charge, -1 oxidation state. For oxidation state means the definition what? The charge on the atoms, charge on the atom, particular atom in a compound. How much charge it is, either negative charge or positive charge present on the atom, that to exhibit which charge, negative charge or positive charge, that is oxidation number. So to finding oxidation number we have one method that we will discuss. Okay. So my next point, if neutral molecule oxidation, sum of the oxidation numbers of a neutral molecule, sum of the oxidation numbers are equal to, sum of the oxidation numbers are equal to 0. This point you should remember. Next, if compound is or molecule is charged means charged. So charged molecule or compound is charged means charged compound. Example SO4 -2. Here S oxidation number what? Like they will ask means what we will do. So that only I will say. Now see, if a compound is a charged molecule means, or charged molecule or ion means sum of the charge oxidation states equal to sum of the oxidation states are equal to sum of the oxidation states of all atoms present in that particular compound are equal to that ions are charged, equal to that ions are charged. So for example, SO4 minus 2 is there. So total number of these atoms oxidation state equal to this minus 2. That is the meaning of this one. If a compound means this one are charged molecules. Sum of the oxidation states are, all the oxidation state of these atoms is equal to this ion. These atoms charges are equal to this ion. We will take like that. If it is a neutral compound, for example H2SO4 is there. Here neutral molecule, that is sum of the oxidation numbers are equal to 0. So these oxidation states all equal to 0. It is all equal to its charge, minus 2, no, minus 2. How it is calculate, I will say. If we don't know but structural formula also, we will calculate oxidation states. How can you calculate oxidation states? I will say. We should memorize all these things. For example, oxygen combined with F means oxygen positive charge will come. If peroxides, oxygen negative charge will come. Negative, minus 1 will come. Generally it is any other element it is combined means we will take minus 2 for oxygen. Like this all things we should memorize. Next one more, I will say. If a hydrogen atom, we know that is always hydrogen atom is always plus 1. But when this hydrogen atom combined with alkali or alkali earth metals. Alkali metals means this one. First a group metals. Second a group means alkali earth metals. So second year means this is these elements and so on so. So these elements when it is combined to hydrogen, oxidation state of hydrogen will be minus 1 will come. So example for this one we will take one Na and H. So here electropositivity which is more, this one no, sodium is more electropositive, so plus 1 will come. For this one minus 1 will come. So now hydrogen oxidation state is minus 1. In this one Mg combined with hydrogen MgH2 will come. Here hydrogen is plus 2, sorry, magnesium is plus 2, hydrogen is minus 1. Minus 1 into 2, minus 2. So hydrogen when it is combined with alkali metals or alkali earth metals, it shows or it exhibit negative charge or negative oxidation states. So these things alone we should memorize. Then only we should calculate with the help of, before I said two points, that is if a molecule is neutral means sum of the oxidation states of all the atoms equal to 0. If it is molecule is negative charge or positive charge means sum of the oxidation states of all the elements equal to that particular charge. We will take that, we will calculate all the elements maximum correct oxidation states. So next class we will discuss that. Thank you.